I'm running a Statpower inverter, puts out 120 volts, 60 hertz from a battery. I'm using this AC output now to test this transformer here. Now I have no load across the secondary output, and I'm making 16.8 volts, and inputs 180 milliamps. I have it in the 20 amp setting right now. Okay, now I'll put this 50 ohm resistor across the secondary output of it, and now it has a resistive load right across the AC output of 50 ohms. The the voltage drops down to 16.1 volts. So the output of this thing right now is 16.1 times 16.1 divided by 50 ohms. That's the watts, the real watts. The input now went up to 190 milliamps. And I'm measuring, the AC output of the inverter. So it's similar to what I did yesterday. Okay, now here's the big test. I'm going to put the same capacitor I put in parallel. Actually, I'll do a 4 UF, which that one's set 3.73, so this is like the same, really. Okay, here we go. Let's see what happens. We're putting in parallel to the AC primary 4 UF cap. Let's see what happens. What do we got? We got a little bit less power, and we dropped the did we drop it? What is it before? No, we raised it big time. Look at that. This is without the cap, this is with it. So that's no good at all. Let's try, instead of a 4 UF, let's try a 1 UF. And now this is a 1 UF in parallel. Here's another one I got. Okay, 1 UF in parallel to the primary. What do we get now? We have the same output, but it looks like the draw went up a little bit. Let's try a 0.1 UF. This will be interesting. 0.1 UF. Draw went down just a little bit. No, actually the draw is just the same. No, yeah, it did go down just a little bit. And outputs 16.1. Same output. Well, so we're not getting anything like we saw with the grid. So now I'm going to put a cap in series on an AC line. One moment. Okay, now cap in series a 4UF cap in series to one of the AC lines. That's what this is now. The draw is now 270 milliamps, while the power went up to 22.2 volts. Okay, one moment. Here's a 2UF in series to one of the AC primary legs. Now I got a little bit less draw, but in consequence the power has gone down. It really doesn't do much good, a 2UF. Let's do a 1UF. Did we do this already? Not in series. So we're doing a 1UF in series. 1UF in series. Oh, now the draw has gone down. Isn't that nice? But look. The power is only about 6.9 volts across that 50 ohm resistor. Well, there's something. That was a 1. Let's try a 0.5 UF. Just a moment. Okay, 0.5 UF in series to one of the primary legs brings the power input down to 0, so I need to move this over to milliamps. .32 milliamps input, but look, we only have 5.3 volts across the 50 ohm resistor. So, I don't know. I'll show you what it looks like on a scope. One moment. Okay, this is the current coming in, and the voltage is very strange. Here's the voltage coming in. I'd say there is a phase shift with that load on it. I'm making 16.1 volts now. It's drawing 200 milliamps. And here's both volts and amps. Here's the amps. Here's the volts. This isn't your normal inverter. So now when I add the cap in parallel, it doesn't do any fizziness at all. It doesn't do anything. You know, I'm going to call it a night. I have tested the output of the AC Statpower. I should test some more. There might be some sort of cap configuration and values that will do some real good, but I don't think I'm going to be able to replicate what I did yesterday with the grid. So, okay, thanks for watching.